welcome to Easy BTech, your guide for BTech and beyond. Easy BTech helps the students to understand the concepts of different subjects easily and prepare well for the examinations and score marks. And it is also helpful for the students to prepare for the competitive examinations as well as for the placement drives. So I am Chari. I teach engineering mechanics. In this session, I give you the introduction about engineering mechanics. Engineering mechanics is first year subject. It is there either in first semester or second semester. In some of the branches, it is there for the second year, first semester also. Most of the students feel engineering mechanics is very difficult. But if you understand the concepts very well, you can do engineering mechanics in an easiest way. Engineering mechanics is based upon the physics, basics of physics, principles of physics, which you have studied up to intermediate or 10+2 level. So the difference between that physics and engineering mechanics is the applications of the principles and the laws of physics to the various problems of engineering mechanics. So I hope so you do well in engineering mechanics after going through the series of videos. I wish you all the best and happy learning. Engineering mechanics basically deals with the forces. Engineering mechanics basically deals with the forces. When you think about the force, you think about engineering mechanics. So engineering mechanics basically deals with the forces acting on bodies. It deals with the forces and their effect of on the bodies. So engineering mechanics is divided into two branches. One is statics and another one is dynamics. These are the two branches of engineering mechanics. As I told you, engineering mechanics deals with the forces and their effect on the bodies. And it has got two branches. One is statics and another one is dynamics. Statics deal with the bodies at rest. Whereas dynamics deal with the bodies in motion or moving bodies. So that means, how do you define statics? Statics is a branch of engineering mechanics, so which deals with the forces and effect of forces acting on the bodies at rest. And how do you define dynamics? Dynamics deals with the forces and effect of forces acting on the bodies which are in motion. Dynamics further classified into two sections. One is kinematics, dynamics further classified into two branches. One is kinematics and another one is kinetics. The main difference between kinematics and kinetics here is kinematics deals with the moving bodies, but here forces are not considered. Forces are not considered in kinematics. And in kinetics deals with the moving bodies, but here the forces are also considered in the analysis. So kinematics is a branch of dynamics, so which deals with the moving bodies without considering the effect of forces, whereas kinetics is a branch of dynamics, so which deals with the forces and their effect on the moving bodies. So this is the basic difference between engineering mechanics, statics, and dynamics, and kinematics and kinetics. As I told you, that engineering mechanics deals with the forces. So we learn about force. How do you define a force? Force is an action. Force is an action which moves a body or which tends to move a body. For example, if you consider a body here, if a force is applied, a push type of force is applied, so this tries to move a body or this moves a body. If sufficient force is applied, so this body moves to the another position. And if the force is not sufficient, it tries to move a body. So force is an action that tries to move a body or moves a body. So SI unit for force is Newton. SI unit for force is Newton. And force is defined from Newton's second law. F is equal to ma. And how 1 Newton is defined? So here F is equal to ma, where F is the force and m is the mass and a is the acceleration. And 1 Newton force is defined from these two quantities. So unit for mass is kg and for acceleration it is meter per second square. So when 1 kg mass is experiencing 1 meter per second square acceleration, then the force is said to be 1 Newton. So force is a vector quantity. Force is a vector quantity. You know from physics, all the quantities are basically classified into two categories. One is scalar quantity and another one is vector quantity. So what is a scalar quantity? A quantity which has got only magnitude but no direction is known as a scalar quantity. If a quantity has got both magnitude and direction, then it is a vector quantity. So force is a vector quantity means it has got magnitude as well as direction. Magnitude as well as direction. And how a force is characterized and what are the characteristics of a force? Characteristics of a force. So one is, as I mentioned already, one is magnitude and the second one is direction and the third one is point of application and the fourth one is line of action. So these four are the characteristics of a force. So I take one example and tell you, let us say there is a body and a force is acting, a force of 20 Newton is acting at an angle 30 degrees with a horizontal line. And now let us say this is acting at a point A here. So in this one, the first characteristic is magnitude. So magnitude is nothing but the value, that is 20 newtons. And what is direction? And it is a pull type of force, and so that is making an angle 30 degrees with the horizontal line. So this one is the direction. So this is up towards right. So angle is 30 degrees. And the third one is point of application, where this force is applied. So this is applied at a point A on this body. And fourth one is line of action. For every force, if you extend this force like this, this indicates the line of action. So this one is known as line of action. Line of action is important in engineering mechanics because whenever a force is taken to any point along its line of action, its external force is not going to be changed. This is important. This particular principle is known as principle of transmissibility of force. Principle of transmissibility of a force. So this principle is quite useful in many problems here. So whenever this force is actually taken to any point along this line of action, there is no change. For example, its effect is not going to be changed. If the same force is taken here, for example, same force is shifted here, and its effect on the body, external effect on the body, is not going to be changed. So this is a useful concept. So we take the force on its line of action, in solving the problems of engineering mechanics. So one more important thing here is engineering mechanics basically deals with rigid bodies. What is meant by a rigid body? A rigid body is nothing but a body which does not undergo any deformation when a force is applied. In reality, it is not so. So whenever a force is applied, there is a deformation. So this is an ideal concept. So this concept is quite useful in the analysis of the problems, so that the same analysis can be made easy at the beginning. This is an idealization. So in this video, I explained the basics of engineering mechanics. Here, what is meant by engineering mechanics, what are the branches, and what is meant by force, what are the characteristics of a force, and so what is its SI unit. And this particular subject is very, very important for all branches of engineering. For example, if you're taking the mechanical engineering, this engineering mechanics knowledge is useful in other subjects in the further semesters. For example, so engineering mechanics concepts are quite useful in strength of materials, design of machine members 1, design of machine members 2, fluid mechanics, kinematics of machinery, dynamics of machinery, and finite element analysis. So this subject also gives a very good analytical ability. So I hope you learn the concepts of engineering mechanics in an easiest way, and I wish you all the best. Thank you.